Hey everyone, welcome back for another deep dive. We are continuing to explore the exciting world of sustainable energy and battery tech.
Definitely a hot topic these days.
It is, and today we're going to be unpacking a recent research article from Northwestern University. It's titled, Transforming Industrial Waste to Power the Future of Energy Storage.
Quite a title.
It is, right? Makes you wonder what they're up to.
Definitely caught my eye.
Well, we're about to find out. They're basically looking at turning industrial waste into a potential powerhouse for energy storage. And that could be a game changer for batteries.
Huge implications if it works out.
So before we get too far, let's kind of remind ourselves why this is such a big deal. We all know about lithium and cobalt. They're the usual suspects when it comes to batteries.
The workhorses of the industry, you could say.
Right. But they also come with some pretty significant environmental challenges.
Oh, absolutely.
Like mining them. It's super resource intensive, and it could really have a negative impact on the environment.
Yeah, and that's not even mentioning the ethical concerns around mining in certain parts of the world.
Exactly. So finding sustainable alternatives is becoming increasingly important.
It's crucial, and this research is a really interesting example of how scientists are tackling that challenge.
Yeah, and it involves this thing called TPPO, triphenylphosphine oxide.
Not exactly a household name.
Not yet. It's actually an industrial byproduct.
And get this. Thousands of tons of it are produced every year.
From what?
All sorts of industrial processes, things like vitamin production.
So the vitamins we take could be contributing to a greener future.
Potentially. Instead of ending up in landfills, this stuff could actually become a valuable resource.
I love that. So how does TPPO actually fit into the battery picture?
Well, in this case, the Northwestern team used TPPO in a type of battery called a redox flow battery.
Okay, and I gotta admit, I'm not super familiar with redox flow batteries.
They're actually pretty different from the batteries we're used to in our phones and laptops.
Which are?
Solid-state batteries.
Oh, okay.
Redox flow batteries are more like giant tanks of liquid.
So like massive batteries.
Exactly. Think industrial-scale energy storage, like the kind of batteries you'd need for the power grid.
Okay, so picture a huge shipping container.
That's the scale we're talking about.
So they took this TPPO, this industrial byproduct, and turned it into some kind of battery juice.
You got it. They figured out a way to convert it into a form that can actually store and release energy.
And how complex is this process?
Surprisingly, not that complex. They developed what they call a one-pot reaction process.
One pot. Sounds pretty straightforward.
That's the idea. Simple and efficient.
And what's really cool is that they managed to create a TPPO-based battery that has both high energy density and stability.
And that is a big deal.
Right, because usually it's a trade-off.
You either get high energy density, meaning you can store a lot of energy, or you get stability, meaning the battery lasts a long time.
But it's hard to get both.
Exactly.
But this TPPO battery seemed to have cracked the code, at least in the lab.
That's what their initial testing suggests.
And speaking of testing, they put this battery through its paces. 350 charge cycles.
Basically charged it up and drained it over and over again.
To see how it held up.
Exactly.
So what happened? Did it survive?
The results were incredibly promising. The battery showed remarkable health and barely lost any capacity over those 350 cycles.
So it kept going and going and going without much degradation.
Pretty much.
That's a really good sign, right? Especially if we're thinking about using these batteries for large-scale energy storage.
Absolutely. Longevity is key in those applications.
And you know what I find really exciting about this? The implications for sourcing battery materials. Imagine if we could shift away from mining.
And towards upcycling waste streams.
Exactly. That would be a huge step towards more sustainable battery industry.
No doubt about it.
Of course, this research is still in its early stages. It's not like we're going to see TPPO batteries on store shelves tomorrow.
True, but that's often how these things go, right?
Yeah.
It takes time to move from the lab to the marketplace.
But that's the beauty of research, isn't it? It opens up new possibilities.
It plants the seeds for future innovation.
And gets people thinking about what could be.
Exactly, and that's what I love about this study. It challenges us to look at waste in a whole new light.
And to imagine a future where sustainability and innovation go hand in hand.
Absolutely. A future where waste is not the end of the line, but the beginning of something new and exciting. It really is like a whole new frontier.
And the researchers themselves, they're not keeping this a secret.
Oh, no, quite the opposite.
They're basically encouraging others to jump in and explore the potential of TPPO even further.
It's like they're saying, hey, we've just scratched the surface here. There's so much more to discover.
Exactly. And I think that's what's so exciting about this research.
It's not just a one-off discovery.
It's an invitation to collaborate.
To push the boundaries of what's possible.
And, it really highlights the importance of interdisciplinary collaboration.
Bringing together those diverse minds.
Chemists, engineers, material scientists.
Working together towards a common goal.
That's how we're going to make real progress in this field.
It's not just about TPPO either.
Right. It's about the bigger picture.
It makes you wonder, what other hidden gems are out there?
What other waste materials are we overlooking?
What other seemingly impossible challenges can we overcome?
If we just approach them with that kind of collaborative spirit.
And that open mind.
Speaking of challenges, one of the big ones in the energy sector is the whole issue of intermittent energy sources.
Ah, yes, the Achilles heel of renewables.
Like solar and wind power.
They're fantastic sources of clean energy, but they're not always available when we need them.
Exactly. The sun doesn't always shine and the wind doesn't always blow.
Which is why we need efficient and reliable energy storage solutions.
And that's where these large-scale redox flow batteries could really come into play.
Potentially using TPPO.
Right. They could be the key to smoothing out those fluctuations in energy supply and demand.
Imagine a world where we could store all that excess solar and wind energy and then release it when we need it most.
So instead of relying on fossil fuels to fill the gaps,
we could be tapping into these giant clean energy batteries.
That would be a game changer.
It would be a fundamental shift in how we power our world.
And it would bring us one step closer to a more sustainable future.
A future powered by clean, renewable energy.
And a future where waste is no longer seen as a problem,
but as a valuable resource.
It's a vision worth striving for.
Absolutely. And I believe research like this is paving the way.
So as we wrap up this deep dive, what are some of the key takeaways you'd like our listener to walk away with?
Well, first and foremost, I want to emphasize the power of innovation.
That it can come from the most unexpected places.
Like industrial waste bins.
Exactly. We need to keep an open mind and challenge our assumptions about what's possible.
And secondly, I think this research really underscores the interconnectedness of things.
How seemingly unrelated fields can actually inform and inspire each other.
In this case, we're seeing how chemistry and material science can play a crucial role in addressing the challenges of renewable energy.
And how those solutions can, in turn, contribute to a more sustainable future.
It's all connected.
It is. And it's exciting to think about what other connections are out there waiting to be made.
So to our listener, I encourage you to keep exploring.
Keep asking those thought-provoking questions.
And keep pushing the boundaries of what's possible. It's amazing to think that something we once considered waste could hold so much potential.
I know, right? And as we wrap up this deep dive, I keep coming back to this idea of TPPO as a symbol of possibility.
It really is, isn't it? It's not just a chemical compound. It represents a whole new way of thinking about resources and sustainability.
Exactly. And it's not just theoretical.
No, not at all.
This research actually shows that it's possible to take something we previously thought of as waste and transform it into something incredibly valuable.
And that's what I find so inspiring.
Give me hope.
Me too. It shows that we can find solutions to even our biggest challenges.
If we're willing to think outside the box.
To question our assumptions.
And to invest in scientific research.
Absolutely. We need to support those scientists and engineers who are pushing the boundaries of what's possible.
Because who knows what other groundbreaking discoveries are out there.
Waiting to be made.
What other waste materials could hold the key to a more sustainable future?
I think that's a question we all need to be asking ourselves.
And, it's not just up to the scientists.
Right. This is a collective effort.
We all have a role to play.
Whether it's supporting innovative companies,
advocating for policy changes,
or simply making more conscious choices in our daily lives.
That we can all contribute to a more sustainable future.
It's about recognizing that our individual actions have an impact.
And that together, we can make a real difference.
This whole conversation has been so inspiring for me.
Me too. It's reminded me of the power of human ingenuity.
And our ability to find solutions, even in the most unexpected places.
So to our listener, I just want to say, keep exploring.
Keep questioning.
And keep pushing for a brighter, more sustainable future.
Because the future is ours to create.
It's been an absolute pleasure diving deep with you today.
Likewise. And thank you to our listener for joining us on this journey.
Until next time, stay curious and stay energized.